In this video, we're going to continue looking at steel wire armoured cables, and we're going to look at the conductor colours and a breakdown of the actual construction of a steel wire armoured cable. In a previous video, we looked at both the BW and in this case the CW glands and all the elements that make those up. So I'll leave a link for that video in the description below. So in front of me here, I've got a 4-core steel wire armoured cable. And we've got the outer here, which is our PVC of our cable, before we've got our steel wire armoured. So this is made of steel, and it's usually used as our protective conductor. But if it isn't used as our protective conductor, we do still need to earth it, even if that's only from one end, because it is metallic and it is electrical. Therefore, the steel wire armoured is an exposed conductive part. Then we've got another layer of PVC here, which is often misunderstood what it's there for. It's actually bedding material from the makers of the cables to give it a round construction. So if we look at the end of the material when I pulled it off, you can see where the 4 cores sat, and the fact that obviously by having this bedding material in there, it made it round in order to get the other layers for the steel wire armoured and the outer PVC. So this is not insulation, it's bedding material. So we've got an outer layer of PVC, we've got the steel wire armoured, we've got the bedding material, and in this case, I've got a 4-core steel wire armoured cable, and the colours appropriate. So we've got 4 cores. And we'd like to think that if we've been working in the electrical industry or we're studying, that we can see that brown, black, grey would be L1, L2 and L3. In other words, our line conductors of a 3-phase supply, L1, L2 and L3. And our blue one would be identified as our neutral. So this is a 4-core steel wire armoured. You might be thinking, Gary, where's the circuit protective conductor in this cable? Well, in this cable, they would definitely be using the steel wire armoured as the CPC. Okay, so that's its conductor there. And you might be thinking, oh, steel's not as good a conductor as copper, because I remember doing resistivity. Well, this is the amount of steel that came off that cable when it was made off. So you can see, even though it's not as good a conductor as copper, there's actually quite a lot of material there to make up that protective conductor. And a rough rule of thumb for me is when we start getting to cable sizes of 16 and 25 millimeters squared, it's the point of which the amount of steel you've got there isn't going to be enough to be the protective conductor on its own, and it might need to be supplemented either by an additional core or a separate green and yellow conductor that would run alongside the steel wire armoured. So when you look up at a cable tray or a cable ladder or a cable basket and you see steel wire armoured cables on them, sometimes you see a separate green and yellow cable running with it, and you might think, oh, that cable is actually maybe for the bonding to water and gas, but it's likely to be supplementing the steel wire armoured, which would still need to be earthed because it is an exposed conductive part, as well as the separate copper cable running alongside it as a green and yellow one if you didn't have a separate conductor. The steel wire armoured, for an exam question, are galvanised with zinc. So there is a zinc coating on these, and it's there to prevent it from corroding. So a question in your exam paper can be, the steel of steel wire armoured is coated in what in order to prevent it from corroding? It's not coated in galvanised, it's actually coated in zinc. The zinc galvanising process prevents it from corroding. So there's an exam question for us. And then we look at the conductors. So we've got a 4-core here, and we'll use this to demonstrate some of the others. So if we've got a 2-core, it would actually be like so. We would have a brown and blue, so we'd have the line and neutral colours identified as brown and blue, and we would use obviously the steel armour as our protective conductor. If we had a 3-core steel wire armoured, we take away the blue one, and we would have brown, black and grey as our 3-core steel wire armoured, and obviously we've got the 4-core there. And then we can go on and look at a 5-core steel wire armoured, which obviously I haven't got in front of me here, but I'd like you to use your logic for this. So if this is 3 lines and a neutral, what conductor colour do you expect to be the 5th core? The 5th core would obviously be green and yellow, so it would be identified as our protective conductor. But once we get up to 5 cores, it can actually be that they're all white and they're identified with a number. So if we go 5, 7 and beyond, all the conductors are white and then identified as and what you need them for. So this is our 4-core steel wire armoured, and it could be that we wanted a single phase supply. So if I move across to this armoured here, and I was thinking about maybe taking a single phase supply maybe from the house to a remote garage, or maybe to feed some garden lighting, and I chose a 3-core cable. It can be now in industry that the 3-core cable doesn't look like this. Sometimes it is brown, blue and green and yellow, and you have to get that specially for that purpose for a single phase supply. But often what you end up using is the standard 3-core in a steel wire armoured being brown, black and grey, and you use it as a single phase supply. So you're going to use this cable to be single phase, not the 3-phase that you'd be thinking about with those line conductors. So if that's the case, hopefully we know that if this is a single phase supply and we're picking one of them as the line conductor, let's go nice and easy. We're obviously going to choose the brown as our line conductor, and it leaves us 2 other conductors that would need oversleeving in order to identify them as the conductor in which we chose them. So we've got black and we've got grey. Now, this is something I always get my learners to sort of reiterate, even though they probably weren't even born in 2004 when the cable colours changed. But actually in the old system, pre-2004, the black conductor used to be neutral. So black colour was neutral, whereas now we're so comfortable with it being blue. So in here, what we don't want to do is slip back to that old logic. So this is our line connection. We're going to choose one as neutral. We're not going to choose black. We're going to deneutralise black, because again, black is one of our line conductor colours. So we actually would choose the grey conductor, identify with a piece of blue sleeving across it, in order to identify that as the neutral if we were using this as a single phase supply. And we would put some green and yellow sleeving on top of our black conductor to identify it as our protective conductor. So that would therefore make that a single phase supply. So the brown would be our line, our grey would be identified with blue sleeving as our neutral, and green and yellow sleeving to identify our black as our protective conductor, where we're using it as a single phase supply. If this was, an exam question often shows you different versions of this, it talks about taking a 3-core cable to a load, and there's one conductor missing in your own mind. So you've got L1, L2 and L3 as our 3-phase, say, going to a motor, and they'll ask you how many conductors will be there. Well, if it's a motor and it's a balanced 3-phase load, you've got to remember from our electrical science and principles, we don't need the neutral. So you can use this to feed a balanced 3-phase load with just our 3 lines, and then use the steel wire armoured as our protective conductor. Metallic motor, etc. is what they use as an exam question in a scenario. So it's the neutral that wouldn't be in that cable. So we've looked at it from using it from a single phase point of view, and if it was a balanced 3-phase load, we wouldn't need the neutral within that cable. Remember, you can also get armoured cable 3-core nowadays that is those colours, brown, blue and green and yellow, and it'd be really interesting if you're using that type of cable at your college to leave me a comment below. The issues start coming when we start interfacing old pre-2004 cable colours into our new system post-2004, because there's some issues there, and I would suggest somebody was having a really good laugh when our old cable colours looked like this. I managed to find this deep in my garage. So our old 3-phase colours were red, yellow and blue. So L1, L2 and L3, and black was our neutral. Okay, so that's the same cable as I've got in front of me here from the point of view from colours and cores. So number of cores, okay, so old 2004 4-core looked like this. Red, yellow, blue, black, and now we're brown, black, grey, blue. Now when we're interfacing them, in other words, joining these together, it could be that you're extending an old cable to a new position within a factory and machines moving, etc. We're going to have to join these together. And straight away, oh right, okay, I've got a blue one, and I've got a black one in the old system, and I've got a blue one and a black one in the new system. Hang on, let's think about this. Under the new system, blue's are neutral. Under the old system, blue is L3, so it's a live conductor or line conductor. Black under the old system was the neutral, and black under our new post-2004 is L2. Whoa, hang on, this has got disaster written all over it, because if we went blue to blue, so if I bring them around here, if we went blue to blue and black to black, we'd actually have a neutral connected to a line conductor, and then a line conductor connected to a neutral, which obviously when we turn it on would make a very loud noise. So obviously that's not going to be the case, and we have to be really careful when interfacing the old and new systems. And we can use the on-site guide to help us do that. So within Appendix K, identification of conductors, in here it will help you understand that interfacing process. And as we look here where we've got a 3-phase installation, it talks about identifying them with N, L1, L2 and L3. So we're not talking about putting a little bit of tape on, we're looking at putting an identifying ring on it that can't be easily removed without opening out the conductors in order to slide it off. So in that case, as we look at our conductors here, we would identify this one as L1, we'd identify this one as L2, and L3, and this one as N, and the ringlet would go onto these, and it joined to our cable, and our new system we would identify L1, L2, L3, and N, where we bring the two cables together in order to interface them. And it's really important that that ringlet goes on in order that we get the correct connection between the two when we're interfacing old and new systems. And it's something you won't come across at college because we'll only be using new cable colours. Just be aware, looking in Appendix K, have a little read through there for identifying them. If it's single phase, so if it was just a single phase supply that we were identifying together, so we've got brown and we've got blue, and we've got black, and we've got red, and we bring those together, maybe in a domestic dwelling, you're used to seeing it extending old systems, you don't need to put those ringlet identifiers on them, on those positions, just where we're going between three-phase systems. Another thing you might notice when you're working with steel wire armoured in a college setting is it's really, really difficult to remove this insulation around the conductors. So it becomes really tough. You're thinking, hang on, this is way tougher than the early jobs that we did in the workshop, which were using twin and CPC cables. So when we remove this PVC, it's a lot easier than removing what you think is a similar material here. They're not quite the same. The insulating material around the conductors here is thermoplastic PVC, and we should know that it has a maximum operating temperature of 70 degrees. So in other words, when we're running it, we can run it as hot as 70. This one here, which is considerably more difficult around the steel wire armoured cable, often isn't thermoplastic PVC. Now in older cables it can be, but nowadays it uses a modern insulating material, which is thermosetting PVC. So it's got different properties with it. Remember, PVC stands for polyvinyl chloride, and this is thermosetting PVC, often called on site, and for exam questions, XLPE. Nice easy one for the first one. X stands for cross. Yeah, that's not very obvious, is it? Cross-linked polyethylene. Thermosetting PVC, or cross-linked polyethylene. That's because it's got an operating temperature of 90 degrees. So when it carries current, it can get as hot as 90 degrees when doing that part of the job. And its material is different, isn't it? We know that from stripping it, that thermoplastic PVCs and thermosetting PVCs have different operating temperatures. Here we have 70 and here we have 90, and we can see that when we strip the cables and how difficult it is to strip. Often the conductors themselves are round on these cables. Okay, they're round conductors, but they can also be shaped. Okay, so these ones are nice and round. They do a shaped conductor as well. So when you get really large steel armoured cables, they look slightly different on the ends than round, but it's still the same. It's so it can form it into a nice circular. Remember, as we looked at that bedding material, we're obviously constructing a round cable when we do so. So there we have our thermoplastic, or is it thermosetting? So think back to the video. What sort of insulating material is this? Often around here it's thermosetting. It's cross-linked polyethylene around these. They do thermoplastic PVC steel wire armoured, but they're not as common now as they used to be. Remember our conductor colours, when we get above 5 core, they start being one colour. They tend to be white and they tend to be numbered. Okay, and if you're thinking about steel wire armoured cable and you're thinking about putting the gland on it, which we looked at in a previous video about the elements of those glands, and you now want to work about putting one of these on, I'll go through how you put a BW20S gland on in the video that is on the screen just there.